All right. Hello, everyone, and welcome to Prompt Engineering for AI-powered systems. We are so excited to have you here today. My name is Adrienne Guy, and I'm the co-founder of Create Her Fest, and I'll also be your technical support for the session. Before we get started, I wanted to make sure everyone is set up for a great experience. If you have any questions or run into any issues during the session, feel free to reach out to me directly. You can use the chat. It's right there on your right-hand side, and I'll be here the entire time to help you out. Just a quick note, you'll see a Q&A feature in your toolbar. Feel free to use that as well on the right-hand side. And if you'd like to share your reactions and your thoughts, you can also use the chat to engage during the session. I'm really excited to introduce you to Alyce Bittar, who's going to be our amazing workshop leader for today. And I'm going to go ahead and pass the mic to her. This is going to be really great, guys.
Hi, everyone. My name is Alyce Bittar, and I am excited to get this workshop going. I'm just going to share my screen, and we will get started. Awesome. So today we're going to be talking about prompt engineering for AI-powered systems with a focus on the pre- and post-processing techniques when LLMs into your applications. So that is going to be with a focus on API integration. And let's just jump right into it. First, I'm going to go over the workshop's agenda. I'm going to give a little bit of an introduction as to what we're going to be talking about today, seeing what LLMs do in the real world and how they generate. And then we're going to go into solutions that we can implement for pre and post processing to make them more robust and what creates a really dynamic system so that you're not having so many different errors show up throughout your application. And then we'll dive into the more specific processing techniques that we can implement. And I'm going to give a live demo what that result looks like and then wrap it up. So who am I? My name's Alyce, and I have been in the engineering field for about 5 years now. I have done a lot of different things from electrical and computer engineering to software, which is more of my focus these days. I have worked at Boston Dynamics and Omni Labs for robotics. And right now I'm currently working at Ringside Pro and a company that I founded with my co-founder, Sarah Johnson, which is called Spoil Saver. And it's actually an app that will be put into beta testing phase soon. That's actually the app that made me really passionate about this topic, because leveraging LLMs into the app allows us to put our product out there a lot faster than we would have without it. So I've gained a lot of value, as well as the customers that we're going to be giving this to. And that has just been really rewarding to see the full process and how it looks to actually implement something like that. At Ringside Pro, I'm actually a full stack mobile and web developer. So I have done a lot of different things in the software. When it comes to things that I'm doing outside of just engineering, I'm a Google Women Tech Makers ambassador, which actually got me involved with Create Her Fest. And I'm really grateful to them for opening up the opportunities for me to be able to speak and host events. So what's today's focus? Today, we're going to be focusing on how pre and post processing of generic models can be implemented into software applications. And this is going to be outlined by prompt engineering, structured outputs, and acceptance validation, and how those can all come together before and after the actual LLM component to be able to streamline everything. So how are LLMs used? There are a lot of real-world applications that we can take a look at to see exactly how these things can be implemented. And although there's like fine-tuned models, the ones that are implemented into more robust and like clear use cases, there's also generic models. So the difference between those two is where you would actually implement them. And a fine-tuned model is more for products that you know exactly what the use case is. You really are invested in spending a lot of time in actually training your own model to be super specific towards the output. Whereas a generic model is something that you might want to implement into a product that is more aligned with the startup phase, or maybe it's part of an application that you're not sure if your users are actually going to gain a lot of value from. So it allows you to create a shorter feedback loop in terms of development and pushing that out to the user. Fine-tuned models take a lot more time because you actually have to collect all of the data that you're going to be training the model on that is specific to your use case and your company, and then do a lot of different processes to make it implemented into your system. So we're not actually going to be talking about that one specifically today. We're going to be focusing more on the generic model that we can implement via API. But when we're looking at fine-tuned models, some examples are screening patient records. So in one case that I am familiar with, there is a tactic that they use in hospitals. Since patient data is like extremely sensitive, they don't want to be having any external access to that. So they train and fine-tune the model within their house for patients to be looked at on a larger scale, and then predict if they will have pancreatic cancer or not. And in those cases, it's super valuable because it can give the doctors an understanding of who they need to pay more attention to if they potentially are screened as high risk for pancreatic cancer. Another one is fraud. So in financial institutions, it can be used to analyze private transactional data within, for example, a bank that identifies anomalies and different discrepancies over data that is input through there. So that's something that can be trained on as well. And then one that us as programmers, of people attending today are maybe more familiar with, is actually the code completion aspects of different models. So Copilot is a great example of this. It is trained on languages that are very specific. So let's just say Python, that allows for predictive generation based on, so that it can give you chunks of code that will help complete what you're trying to do before you actually get there. And that differs from the generic model, for example, because you don't actually have to train a model super intensively if you're looking at things like bugs or errors. Those are more generic model based. So just in terms of programming one, you can kind of see the difference there. But some of the generic model implementations that we can take a look at is in real estate. So natural language search is really helpful in that realm because it allows people to search for things like historic beach houses in a busy neighborhood. Whereas just using filters, it might be a lot more difficult to find things like that, and it makes it a lot more user friendly. And then also for productivity apps, so Spoil Saver, the app that my co-founder and I are working on, is a great example of this. It is an AI-powered app that helps users save food by getting notifications before they expire. And a lot of the data that we estimate is generated using an LLM. It's using the Gemini Pro model. And what it helps us generate is storage recommendations and expiration dates that we can then notify people on, let them know where they should put certain food throughout their kitchen. So how do LLMs generate output? Once a prompt is fed into an LLM, it goes through a set of steps to come up with a valid response. An input text is broken down into smaller units, which are called tokens. And as you can see right here, where it says hello, comma, world with an exclamation point, it can be words, subwords, or even characters that it will break prompts down into. The model then uses transformer architecture layers to process these tokens. It builds a context-aware representation of each one by considering its relationship to all the other tokens being processed in parallel from the input. So if bank is a part of the prompt that was created into a token, it will look at the context surrounding it in terms of the other tokens processing and see what kind of bank we're looking at. Are we looking at a river bank, or are we looking at money in the bank? And then it will choose associated contextual values to then create the next token in the sequence that it's generating and accepting. This helps the model produce relevant outputs based on context rather than specific words that it doesn't understand the meaning of. And then from there, it goes to the output delivery, and the user can see what it has generated. In between number 1 and 2 and 2 and 3, there's another step that I abstracted from the picture here, but essentially computers do not understand human language. So all of this tokenization and model processing happens on a number basis. So things are decoded between 1 and 2 and then encoded between 2 and 3 so that the data that's generated is natively being spoken in the languages that the output is happening in. So within the LLM, it's all numbers, and then as it exits the LLM, it is back to words for us to understand. So when we're thinking about building a robust system when implementing an LLM into our products, we want to take a more holistic approach rather than just looking at the LLM itself. So on the right side here, you can see that we have 4 different items that we have defined here. The first one is the pre-processing that we're going to be doing. And that is defined as the engineered prompt. So what does that look like? How can we make it the most efficient for the LLM itself to be able to understand? And the second one will be what's happening in this black box. You'll hear me say that topic, like that name a few times, but when it gets to the point of actually processing data within the LLM, we can't really see what's going on. So there are a few techniques that we can go about there to help refine what we are expecting. And then there's also the post-processing techniques that we have. And these are the structured output validations, and then also validating what has been output and structured to know if it's correct for what we should show to the user, or if it needs to re-trigger the LLM to have a new output if it was a hallucination or some sort of data that came faulty. So when it comes to engineering your prompt, there are a few different things that we can go about looking at here. Let's see. When engineering your prompt to help refine the generated LLM output, 4 different considerations can be implemented. The first one is defining a persona. So this helps it think more like a human within a specific role. I'm going to give a demo later on the result of what this looks like. But essentially, when you define a persona, it gives the LLM an understanding of how it should be data from what it has been trained on. The second thing is incorporating variables into your prompt. So say your user is selecting different parameters that are specific to their request. Say they're looking for a specific destination, when they're getting somewhere, and how long they're going to be there. So if you're a travel assistant, you need this to be able to accurately tell your user exactly what they're looking for. Next, we want to provide a data structure that we're expecting. So we want to define the desired data structure that you'd like to implement and give it an example of exactly how that looks. I found that when creating this example, it's best not to use exact numbers and values, because it then tries matching it almost. So you want to give it more open-ended examples so that it can take it as a reference rather than a template to use. And the next thing is requesting the data structure that we're expecting. So we want to define the desired data structure you would like to receive from the LLM to most effectively leverage it in your app. And what that means is, say you're creating this app that we're looking at right now, where you're asking for a list of items to pack for a specific location and trip. You want to be able to show that to your users after the output is created in a structured way. So say a list with headers and bullet points. In this case, where we provide the output example, we're doing it in a key value pair structure, which allows us to better process the data on the back end and use that structure to validate whether it produced correct information or not. Also, don't forget, during the testing of the implementation of your LLM, you're definitely going to have to tweak things around. And a funny thing is that I've always found it to be most effective when I actually work them in their chat, like ChatGPT, for example. If I go to ChatGPT and I say, what do you think of this prompt? I give them some context, what I'm looking to receive on the back end, and it will actually help me refine and clarify exactly what it needs to trigger producing the correct output. So what is the black box? The black box is the LLM itself. Once you feed something into it, you don't really see what's happening until it produces an output. But there are a few different things that we can do to help refine this predictive generation process. And we can tweak the different parameters used during implementation to help the model focus on what we're actually for. One of the best ways of doing this is using the sampling strategy. The sampling strategy is a tactic we can use to tweak LLM parameters during the testing phase to fine-tune the desired level of creativity using temperature, for example, control the range of token samples considered using top K, and adjust the selection probabilities using top P to achieve the optimal balance between precision and diversity in the generated output. So if we take a look here, these are the different parameters that we're going to be looking at. We have number 1, which is temperature, 2, which is top K, and 3, which is top P. If we look in the leftmost image, the weighted predictions for what the LLM's considering to be the next token in the sequence is weighted. The temperature defines how creative the LLM should be in creating these based on the context we spoke of earlier. In the center image, once all of the different tokens are created in terms of options of what it can choose, top K shows 3. That's the one that I chose here, which is defined for top K, used to refine the range of tokens used to refine the range of token samples considered. So you can see here on the left image that there are 6 different options. And then by using top 3 as the top K parameter, we only take the top 3 options of that list. So in LLMs, they can generate 50, 100 different options as tokens, and refining that throughout this iterative process helps us streamline exactly what we're going to be looking at. The rightmost image shows how top P further simplifies the options by adjusting the selection probabilities. So out of the top 3 that we chose from the initial subset of tokens, we choose 70% of that, and that gives us an even more refined version of what the final output may be. At the end of calculations made during the sampling strategy, we only have a select few. This allows us to make our calculations a lot faster, because rather than having the LLM try to choose between 6 different things, it only has to choose between 2 to give you the best result based on the parallel context that it's also handling at the same time. We ask the LLM to structure the output in our engineered prompt. Sometimes things go wrong and data is not always returned as expected. To further safeguard the data that you're handling within your app and make your LLM's integration more robust, we can put checks in place to ensure the data is structured as expected. After the model generates the output, you can apply post-processing rules to convert unstructured responses into structured formats. such as parsing plain text into JSON, key value pairs, CSV, or any other one that you would like to use. Here's an abstracted version of how this works. So if the API generates the LLM output, a question we can ask it is it a JSON turned in the actual JSON object data structure? And if it is, then we can push it on to the next step of our post-processing. But if it's not, we can use that opportunity to convert it into something that we're actually expecting, which is, in this case, JSON. One of the hardest challenges when implementing post-processing algorithms is validating that your implementation is correct. LLMs usually have a large vocabulary, and it's hard to know the expected output. Here are some of the most efficient validation techniques so that users can experience errors less often, and things are happening on the back end to check whether that is whether what the LLM generates is correct or not. The first one is rule-based validation. This helps us define clear rules to ensure outputs adhere to expected formats or constraints. An example of this would be dates. So say you're expecting a date to come out of your LLM. It's not in the year, like YYYY, DD format, where it's year, month, date, or it's undefined, which is an edge case. We can convert it at this step. Or even, as we're going to look a little bit later in the fourth item here, which is error feedback looping, we can actually feed the error that we have created from different checks into the API again to then generate a more accurate response. The second one is functional and edge case testing. We can develop unit tests each step in the post-processing pipeline, including edge cases that test to verify handling of unused empty strings or rare tokens. When it comes to ground truth comparisons, we can use predefined datasets with correct outputs as a benchmark. So it's essentially doing a minimized version of fine-tuning one of the custom models that we were speaking about for larger enterprise applications. And we can do that locally to our project so that it has some sort of reference as to what we want the output to actually look like. And these metrics can be applied through things like blue, rouge, or exact match scores to quantify performance. Back to the fourth topic here. You're going to see this a little bit later in our demonstration that's coming up. But we've implemented a max validation attempt as well as this feedback loop of the error that is generated from different if-else statements. So we have a bunch of different edge cases that we account for. And based on that, we're able to actually create an error message that can be fed back into the LLM and help refine the retry of expected output. And then once as you can see here, there's a number of attempts and a max validation attempts. So right now it's on 2, but if it was to hit 3, it would actually tell our system that it does need to tell the user that there's an issue. And this is in real world applications, it looks like saying, oh, like, or what, our site is not working at this time, please refresh the page or try again later. Things like that to just kind of redirect the user to either a different portion of our app or to let them know that it will work, but they might need to retry. So you can kind of customize that error message to your specific application and make sure that I'm using the term like error message, but it doesn't necessarily have to be like error, something's wrong. You can just kind of divert their attention to something that is a little bit more user friendly. Okay, so now I'm going to go into the demo. I'm going to actually take this link and send it to you guys. So just give me 1 second. I'm going to put it in the chat for everybody to see. All right. I'm going to give you a little overview of it going on here, and then I'm going to run through the use case of how a user might experience it. So this is a packing list generator. It takes a user input in terms of a few different parameters, and it passes that to the server layer, which imports all of the data into our engineered prompt that we took a look at earlier in the presentation.
Hey, Alyce.
And then
Alyce, there may be a path issue with the link because we are getting a error 44 error code.
Okay, give me 1 second. Hopefully
something missing from the path.
All right. How about that one?
Let's check it out.
Perfect. Oh, you guys aren't able to see what I was showing. Oh, whoops. Let me just reshare screen.
That link does resolve though, so that's perfect.
Okay, perfect. This is what we're looking at, just for clarification. I'm glad you guys let me know. So, as you can see here, I'm just going to kind of restart that section. We have a packing list generator. There's 3 different columns. The first one is what the client sees. The second one is operations are happening within the server. The top one is the pre-processing, and the bottom one handles the post-processing. And then on the right side, that is our API handled portion. So once we generate the packing list, it's going to send and populate our engineered prompt with the different variables, pass that to the AI model, and then it's going to give the response our parsing and validation box at the bottom. And based on whether it is accepted or not, it will either retry the engineered prompt with the error message as context for it to try again with more information, or it will give us the structured output as we expected. So let's try. I'm going to go to Japan, and I'm going to choose, I'm going to say June 25th. I'm going to say I will stay there for 15 days, and then I'm going to generate. All of the information was added into here. It was passed to the AI model. As you can see, it was generated, and it passed our validation and parsing aspect in terms of the post-processing, returned a structured output, exactly what we were expecting. So it gave us the packing list, it gave us some information about the location. It tells us that during our stay in Japan on that date, the weather is expected to be warm and humid with occasional rain showers. So it actually uses the weather forecasts and general travel needs for that specific location as defined in our prompt right here. And that context and the persona, which is the travel assistant, to actually generate this. I also included, which is abstracted from the slide that I did earlier on engineering your prompt, but I added a few more things that I would like it to consider. So what may not be necessary, it gives like a little asterisk at the end, and then it also generates a number of items with there being a limit on a maximum of 7 for the larger clothing items and things like that, so that it's lean in its generation. And I know that it is working. Oh, did I specify a bulleted list? No, so I didn't specify a bulleted list. What I actually specified was that I wanted it to be returned. I wanted the LLM to return the output in key value pairs, and where the key is the header, like for example, location info, that is right here. And then there is an array of strings defining each of the items that I, on the post-processing side, will convert from the array of strings into bullet points. And that's actually part of the like data structuring portion of the post-processing technique, is that first I go through the output and see if everything is in a key value pair. And then I go one level deeper to see if the value is structured in an array of strings. And if any of those are undefined, it re-triggers the engineered prompt to be to the API, and then it redoes the validation and data structuring portion before it sends it out to the user as a structured output. I'm going to go back to my question because I do have an example of what it looks like when there's a problem. So let me just see if you guys can see this. I think I have to reshare. 1 second and I will get back to that. Okay. All right. So I'm hoping you guys can see this. Yes. This is the example of it working correctly for who didn't check it out on the website link. But when it doesn't work correctly, where the output is not returned as expected, this is an example of how the validation loop works to only give the user a result if it has tried at least 3 times. So here it doesn't give it in the correct data structure. So it sends that information back, as you can see in this little red error feedback. And then it passes that back to the AI model, which then uses it to update the information. So after 3 times, you can something went wrong and it's asking you to try again. And at that point, after it tried as hard as it could internally, it passes it on to the user. But the benefit of this is that doing all of this, like implementing pre and post processing, especially the post in this specific case, really allows the user to have the best experience possible. when it comes to implementing this black box that we're not really sure exactly how it's going to react. So yeah, if you guys have any questions about the entire process and pre and post processing techniques were implemented to create a really robust application experience, drop it in the Q&A or in the chat, and I will get to those now. Okay, so I see this first question in the Q&A. It says, are you caching prompts or outputs in order to preserve context between session and save tokens? So in the specific case that I showed here, I am not doing that just because it's a demo. And each time that you are going to be generating information using the LLM, it's going to be different. One of the things we can do in terms of using a cache is that, like you said, we can provide the context that we would like. So say they're always going to be a travel assistant that is keep in there. The different parameters and the structure can also be abstracted into a prompt that's cached so that it doesn't have to handle such a large prompt every single time. So that is definitely something that I've used in the past to that like has preserved some of the context so that we're not re-triggering at a very costly expense. And in terms of saving tokens, it depends on your application. So if you see it as being beneficial to save tokens for certain instances, say for a chat, for example, you want to implement a chat in your application. You can use those tokens that were previously generated also as context to help a more customized output for your user. The second one are the levers you mentioned in Gemini, like temp, top K, and top P, available in other APIs like ChatGPT and Gemini? Yes, they definitely are. Every LLM API that I've leveraged actually allows this. So ChatGPT definitely allows it, and Gemini also definitely allows it. They do have documentation on it so that you can take a deeper dive into exactly what implementing that looks like. But you're going to have to just play around with it and to really understand how it affects the output, because it can vary quite a bit. Like, sure, related to my demo is when I was playing around with that portion, if I made it really strict and I wanted like really predictable outputs, it would generate locations for me to visit in Japan that were landmarks and things that are really well known. But if I made it more creative, it would recommend things like go to a garden and have Japanese tea made by natives or whatever. So it really varies quite a bit, and you're just gonna have to play around with that based on the application that you're looking to implement. The next question is, how does this fit in the tree with other AI list? This is from Catherine. I'm a little bit confused on your question, so if you can maybe send another one that's a little bit clearer, I would appreciate that. When it comes to the next question, let's see. How can we add the option of choosing specific LLM model for LLM processing or configuring parameters as a user choice. So in that case, what I'm thinking that you're referring to, please correct me if I'm wrong, but what I think you're referring to is the like being able to choose between different models within ChatGPT to output that you want. Like say you want a image generation versus a text generation, and you want to, as the developer, create a kind of landing page for where you can access all these different LLM versions. I, in that case, would probably them all as individual models and then create some sort of toggle that will point the LLM generation to those specific ones based on the user's selection. Let's see. I am back in the general chat because I answered all of the questions in the Q&A. So let me just see what we have here, if there's any others. Okay, I got yours, Liz. Oh, I'm glad that people are trying it out. Okay, perfect. Okay, so last question. Is weighing out possible? I asked GPT to include the Expo topic when React Native quiz questions are generated. Now most questions are about Expo. So that's actually interesting, and that's one of the things that I mentioned earlier. I'm going to go back to that slide. But let's see, just to dive in a little bit deeper, when I am pointing out providing an output example in your prompt when you're engineering it, I want to try to be as open-ended as possible. So maybe instead of saying just Expo, give a few other options for it to leverage, because it's going to latch onto those things and try to generate what you want. And if you're specifically asking for Expo, it's going to think that that's exactly what you want. It can't really generate information. It can, but only if you give it the creative option to do that. Let me just think. So maybe something that would be helpful in that specific case, Liz, would be to have the user input exactly what they want to study for, and then using those as variables within your prompt to then help the LLM clarify exactly what it's generating information for. Okay, let's see. The next question is, how do I say I want 80% of quiz questions related to React Native and 20% related to Expo, for example? Let me just think about that one for a second. I think my personal approach would probably be getting a generation for both. And then, like we were talking about in the parameters, we can kind of create a percentage that we're accepting from the output that's generated, and then just parsing those things together on the back end before showing it to the user. That might be a little bit more efficient, especially since if you're going to be asking for these two different things within one huge prompt, it's going to be a lot more costly than potentially doing two smaller prompts that ask for those things specifically and then doing the filtering on the back end. Let's see. Catherine, she sent a question that says, will the output be rejected if just in a header list? Yes. So the way that I structured my validation checks is that if any of either the headers or the value in any way is empty, so if anything is undefined, it will reject it and ask for it again with that context in terms of an error. So, for example, if the header is clothing and the array that follows is a few blanks, and then it has shoes, and then it has socks, and then it has underwear. The second portion of the validation check goes through the values to see if all of those are valid responses. And if they're not, then it's going to feed it back through the loop. So that is how I personally have implemented it. And you kind of have to be creative for your specific use case. But yeah, that's definitely one approach. Alrighty. It doesn't really seem like there's other questions. I'm just going to leave my socials here. Anyone to follow me. I'm on Instagram, LinkedIn, Facebook, anyone that you can imagine. And I would also really appreciate if everyone would check out Spoil Saver on the website. It's currently in the beta testing phase, and we're still working out a few kinks, but we would love to have you follow our socials so that you can join us along the journey and be part of our community. Thank you so much for having me, and I will hopefully see you guys at future events.
Amazing. That was a great workshop. And thank you for taking the time to answer all of these questions. We have a bunch of claps, snaps, and thumbs up as reactions. So we can go ahead and wrap up this session now. But I just want to give another opportunity to all of our participants to give Alyce a round of applause for her amazing workshop. Thank you so much for joining us and for contributing all this value to our community. We will be posting the recording on our YouTube, and you can find that on our YouTube channel at Create Her Fest on YouTube, as well as in Discord. We will also be hanging around a little bit. So if anyone has other questions or you're super excited and you want to find out how you can connect with Alyce more or learn more about what she does and how she builds with these tools, then you can hang back and network a little bit in the remote. And I'll go ahead and wrap us up. Thank you, guys.
I also just wanted to thank Create Her Fest for hosting this entire workshop and all of the different events that you guys are putting out there. They've been really great to be part of.
Thank you. It's great because of you guys. So we appreciate it. But hang around
Right.
if you guys want to know more.
Yeah, it wouldn't